Hello everyone and welcome back. We are now switching from QGIS to GRASS GIS. And right here I have the GRASS GIS website open up. The URL is grass.osgeo.org. And obviously the first thing you're going to want to do is to download and install GRASS on your computer. So just click here in the download tab and you'll find your operating system. And you will click the button for which operating system you have. For most of you, that's going to be either Windows or Mac. If you are going to install for Windows, you have a couple of options. You have the standalone installer, in which you can install just GRASS version 8.4 by itself, or you can use the OSGeo4W installer. And that is a sort of meta package that allows you to also install a whole bunch of other GIS software, including QGIS. And if you want to work with GRASS and QGIS sort of in tandem as a team so that you can work with GRASS modules and GRASS data from within QGIS, this is the way for you to install both pieces of software so that they'll play nicely on your system. If you just want to use GRASS by itself, then go ahead and do the standalone installer for Windows. For Mac, again, you have a couple of different options here, but you're probably going to, most of you are going to want to install the current stable standalone one. If you're a little bit more technical and you want to get the same level of interaction, like I mentioned for the Windows installation, then you'll follow the Mac ports instruction. But again, that's a little bit more technical than probably most of you are, in my class anyway, are going to want to do at this particular moment. And if you click here, you can see that this standalone version has some really important instructions. Same thing with QGIS. There's a little bit of a rigmarole you have to do with the Mac OS security just to get around their restrictions, which is basically a little tax that Apple charges on developers. GRASS is safe, the code is safe, it's not going to damage your system, it's not malware, it's not Trojans or viruses or anything like that. It's just an open source project that doesn't currently have the resources to be able to pay that fee to get around the security. Okay, so following the instructions, you will get GRASS downloaded, and when you do, I'm just going to move over to this Quick Start tab. I'm just going to start GRASS on my own. You're going to see an introduction screen the first time that you start it. Now, I've been using GRASS forever, so I don't have the introduction screen anymore. You'll see the little splash like this. You may see a terminal, you may not see a terminal, depending on how you install GRASS. And then the very first time, you might see this just big old blank window like I have here. Let me just shrink that down a little bit. And then map display, and then you might have a terminal like this. You may also see this message that says, you need to download the sample data. So go ahead and do that. Follow along so that you create the initial blank location and map set, or at least a lat-long location and map set, so that you can start up GRASS and just see what it's all about. And the first time you're going to get this, what we call the multi-window interface, and that has been the default sort of windowing interface that GRASS has had for quite a while now. But I have actually switched to, they have enabled a single window interface. So before we do anything else in GRASS, what I'm going to do is to show you how to switch it to the single window interface, because then it will look a lot more like QGIS, and I think cognitively that's going to just help you learn the software a little bit better. So before I tell you anything else about it, what I want you to do is to find this window over here that has maybe the first GRASS location data, which will be this world lat-long WGS 84. And find the menu item that says Settings, click it, and click on Preferences. And then under the Appearance tab, click this button that says use single window mode, and it says require GUI, which is the graphical interface restart. Just hit save, then quit GRASS, and start it again. And again, as a new user, you just quit it completely and start it again, and it will go through the splash screen again, and it will get you back to the new interface, which will be the single window mode. And it will look a lot more, just expand it, it will look a lot more familiar to you. It'll look a lot like QGIS, right? So basically we have our file tree in the upper left, like QGIS. We're going to have our layer manager in the bottom right. We're going to have our sort of info window over here on the right, and then our map display is in the middle. So I think this is going to help you cognitively make the switch from QGIS to GRASS a lot better. So I already have a bunch of GRASS projects over here, but let me quickly break down how GRASS manages your data. You can read through the quick start, that's what this is. You can get that from the GRASS website. But let's talk about a little bit of the philosophy of how GRASS is going to manage your data. I've been telling you in class, if QGIS, you got to create the folders. You got to come up with the system of rasters and vectors and putting them into this folders and putting your project file in a specific place. With GRASS, the philosophy from the very beginning was that we are going to do that for you. We are going to force you to get all of your information to be reprojected into the same CRS, and when you're working in that CRS, all the data is going to be in a folder that we keep, and we keep it a little bit hidden from you. So with GRASS, you need to import data into the GRASS formats for rasters and for vectors, and it will force you to organize them in this way. You firstly have something called databases. These are upper level folders, if you want to think of it that way. We called our QGIS folder GIS projects. That's what this database is. The default has been to call it GRASS data, but you could call it anything that you want. And you could have multiple databases, and you can keep them separately in different places. Now, I have my system set up like that. But you only need just one database. Within the database, you need locations. And locations are like individual projects. And more so, they're individual projects that everything within them will share a specific CRS. And so sometimes the location will be just that CRS, UTM Zone 36 North, for example. Or it might be an area that you're working in, Wadi Hassa, or something like that. But everything within that location is going to be related to one project. And then within the location, we have what we call map sets. And these are lower level folders that you can use to organize sub-projects within your location. You at least have to have one map set called permanent in all caps. And permanent has a few files in it that save information related to the CRS, to the projection system, and to the resolution, and to the region that you're currently working in. And you should also put your base files, when you import them initially into your location, in permanent. Your base DEM, your base site points database, that kind of stuff should live in permanent. And then you should never be working within the permanent map set. It should be just like specially reserved for your base data. You create a new map set, which is like a blank folder, and anything you do will save into that new map set automatically. And that's basically what's below over here. Rasters and vectors and all of this other stuff, they're going to be formatted in the GRASS format, and they're going to save automatically into these things, and you will never have to go physically navigate on your computer's file directory system to look at these things. You're going to manage all of that from within GRASS. That's the philosophy that GRASS basically works with. So all of this stuff over here is data that is imported into GRASS, into a database, into a location, and into a map set. And it's all going to be organized in that way. So this particular one, which is a basic GRASS data folder, has some of the sample data including the world lat long WGS 84, which is what GRASS, when the first time you open it, it will ask you to create that somewhere on your computer. Put it somewhere sensible, again, not on your desktop, maybe in your home folder like I have over here. And that way you can navigate to it and take a look at what it is. So here it is on my computer, and you can see these are the actual folders that you're looking at over here. And if we open up this one, we see a map set permanent. We see maybe you'll see this .grass thing. This is a hidden file. And if you open permanent, you'll see all of these other folders that GRASS creates. This is where it's going to save all the data, in its own format when you import GRASS into it, right? And then it has all of these text files. These are the little files that it keeps the projection information and all of the resolution and all of that stuff in here. So permanent has a lot of this stuff, but every map set is going to have these. But you don't have to go into your computer and mess with any of this stuff. You deal with it from the GRASS interface over here. The one time that you have to get into your GRASS data folder is when you want to take somebody's existing GRASS location and put it onto your computer. And you're going to do that for project 2. So here's the project 2 description, and basically you're going to download project2.zip just like before, and download over here and give it a second to do its thing. And we're going to navigate to our GRASS data folder right here. And we're just going to save project2.zip right into that folder right here. I'm going to hit right click on it. I'm going to extract here. And project 2, actually technically what we should have done, let me back up. I'm going to move this to my home folder like so. And instead of in my existing GRASS data, I'm going to find my project 2 zip, there it is, and extract it right there into my home folder. And this contains a GRASS data folder within it. I forgot the way that I had organized it. And here is the location and our first permanent map set. Okay, so once we have that extracted into our computer, we need to go back into GRASS and basically point it at that. So over here, we're going to say add existing or create new database, this little button over here, this window that pops up. We are going to navigate to our project 2 GRASS data. We're going to highlight where it says GRASS data, and then we're going to click open. And as long as we highlighted GRASS data and we didn't go beyond that, it will know that this is a GRASS database that has one GRASS location that has one GRASS map set in it. Okay? Okay, so inside permanent, if we double click on it, in this manager over here, we can see that we have basically our 3 pieces of data that we've already been working with in QGIS. Now, I have already created this GRASS location, made sure that it has the right CRS, and I have imported all of this information, all of the layers into GRASS so that they're in native GRASS format. Later on, I'll show you how to import data into a location and how to create a new location from scratch. But for right now, this is what you need to do to get going. And, obviously you're not going to have as many databases as I, but what you need to do is to tell it to which one of these locations and which one of these map sets you want to be working in. And every time you're doing something in GRASS, you need to switch into a map set. Now, the obvious thing to do is to right-click on Permanent under Wadi Hassa WGS UTM Zone 36 North and click Switch Map Set. And GRASS will think for a little while, and now you see where it says Current, right? If I do anything at this moment, it's going to be saved in Permanent. This is not a safe working situation, but I did this just so that you can see how to move into a map set that already exists. Now I just double clicked on the SRTM and it puts it into the layer manager. And I'll click on the WHS sites and it adds it into the layer manager and shows them in the map display. Okay, so we've got permanent, but what we need to do is to make, every time we're going to do a set of operations, we should make a new map set so that we don't accidentally overwrite or delete our base data files. And there are a couple ways to do this, but the easiest way is to highlight the location name. And again, this is for us the HASA WGS 84 UTM Zone 36 North. Right click it and hit Create Map Set. And by default it puts whatever your computer's username in here, but let's make a new one and let's call it, I'm going to show you a couple of distance analyses. So let's just call it distance analysis, right? It's useful to name your map sets over the types of maps that you're going to create within them. And now we see here we have permanent and we also have distance analysis. And since we just created it, it switched us into this map set. This map set is blank. There are no maps in it, but we still can access the map sets that are in permanent. Now, the more map sets that we make, the more folders are going to be down in here, and we're going to want to set up whether we want to be able to see all those maps, but maybe we want to hide away some of them. So what I'll show you is under the settings, we'll go to where it says GRASS Working Environment, and then the first one says Map Set Access. And here, all the map sets in your current location will be listed, and if you don't want to see the maps in them, you just sort of uncheck them. By default, permanent will be visible, but you may have 5 or 6 or 7 or 8 of them, and you don't want to see maps in all of those folders necessarily all the time, so you can uncheck them. On the other hand, maybe you want to access some of those maps, but you want to save them in the current map set. You have to make sure that the check mark is checked so that you can actually see the maps from within the interface, the interfaces of the various GRASS modules. Okay, so here we are. We've got our location. We've made our new map set. We've got a few data files. We've got them into the map display. You will see some very familiar looking tools. You can pan around. You can zoom specifically by drawing a box. You can use your mouse wheel like I just did to zoom in and out. You can go back to the previous zoom by clicking some of these buttons over here. You can zoom to the maximum extent of whatever layer you're currently showing over here. Over here in the layer manager, once a map has been added, you can right click on it, and again, properties, not exactly the same as what they look like in QGIS, but the same idea. You can set the color. This is the WHS sites, so let's set the symbol. Right now they're X's, but maybe we want to make them circles. Okay. If I hit apply, it will show that in the background, and I don't want them blue. Let's say I want them red. And I hit apply, and now I've got red. Right. So all the same kinds of interactions that were possible with the symbols in QGIS, for the most part, are available in here. Same thing for the SRTM-DEM. By default, it uses this Viridis color scheme, but if I right click and I go to properties, then I can go, oops, not properties, right click and go to set color table. I can hit on the define tab. I can pick whatever color scheme that I want. Let's pick this elevation one and hit run. And now we have this color scheme. Now, you may like that, you may not like that. But if you want to change it, go back to set color table. Define tab, and then go ahead and pick whatever other one that you particularly might want. If I go down to the bottom, I think there's actually a terrain map over here that works really well. Well, not in this particular case. Let's pick, SRTM is the one that I wanted to pick that works really well with this particular information that we have here. Okay, so here we are. We have our color scheme set. Now, with GRASS, the color scheme gets saved with the actual layer. So if we start GRASS again, the SRTM is going to be this color every single time until we go in and change it specifically to a different one. That's a slight different way of doing it than with QGIS. However, the vector styles don't get saved. They are independent of the actual files, right? But we can, like in QGIS, save a project file in GRASS so that we can get right back to what we're looking at. So if we really like what we've got here, we go to File, Workspace, Save, and then you can save it anywhere. Unlike QGIS, it will actually work okay because GRASS forces all your data files to be in its format. You can't break that connection in the same way that you could break it in QGIS. But let's go ahead and save it under Project 2, and we'll just call this Wadi Hassa GRASS Project, something like that. And it will save it with this .gxw format, which is literally just saving the styles and the layers, what we're currently looking at. Okay? All right. Let's talk about a couple other important things in GRASS. Because GRASS forces all your data to be in the right CRS, once you've got your data imported, you don't have to worry about the projection. All the data that is in my WGS 84 UTM Zone 36 North location has already been reprojected into that CRS. It's going to line up exactly, and we don't have to worry about it because anything new we make will also be in this projection system as long as we stay in this location. So even if we make new map sets, all those map sets are still in that CRS. The one thing that we can control while we're in here is the window size, the region with which we're working. Now by default, you see this pretty big region size that is set to the same size as the SRTM tile. We can change that if we only want to work in a smaller area. So let's show you how to do that. Grab the zoom tool, zoom in to an area that just surrounds the actual sites themselves, and it zooms in like this. And the very simplest way is to find this little button that says various zoom options and says set computational region extent from display. And when we do that, the little red boundary that you see is going to be the area that we're working with. And if I zoom back out, we see the little red window is showing us this is the only part of the map that we are going to be working with. So if I make any new maps, it's not going to go all the way out to the edges of the full SRTM tile anymore. It's only going to go within this red box. This is super useful because sometimes you're working with big data sets, but you only need to work in a small area, and it will just make everything go faster because you're giving the computer less ones and zeros to work with. This can also be confusing because you may have forgotten to change the region to the area that you want to be working with, or to expand it back out, and you'll do some stuff and you'll be like, where's my map? Why is my map only in one little area of the whole zone that I want to work in? You have to remember to set the region every time. And every single time that you are working in GRASS, you want to double check what my region window is. Now we get this nice little red box, but we didn't used to have that in GRASS. So old users of GRASS just know this. New users need to know that with this red box is where you're going to be working. And you have some tools up here. You can set computational region interactively. So you can actually draw the box like so, and you can change it on the fly like so. You can also save a region that you currently see. So this currently red box, I can call it zoom in West Hassa, like that, or something like that. And now if I change my computational region, like to be the whole area, so you can see it's actually bigger than the map, like so, and I can actually set the computational region from named region, and I can pull down here and find my zoom in. And there we go, right back to that, right? I can also, over in the Layer Manager, right-click on a map and set computational region from selected map. And now I've set it back to the full extent of this particular data layer. But if I did it for the other one, for the WHS sites, you can see it'll zoom right in just to the region that is circumscribed by that. Now that we know that we have to set that, there's one other piece of information that we need to know, which is the resolution of the raster grid that we want to be working with. So right now we just have the SRTM. We can right-click on it and we can click where it says metadata. And over here in the right window, the sort of output display window, we get some information about this particular GIS layer. We get the actual region extents in UTM coordinates, but we also get the horizontal resolution in the east-west and north-south direction. And the SRTM is a 30 by 30 meter resolution. Everything that we do, if we match our computational region to this map, is going to take place within these boundaries and at this 30 by 30 meter resolution, right? So if I click Set Computational Region, then my computational region is going to be exactly the same as this. And if I go up to Settings and I click where it says Computational Region and I hit this Show Current Region, it will show me that we are at a 30 by 30 meter resolution and that these are the boundaries which match exactly these boundaries of that map. If I want to work at a different resolution, let's say 15 meters or coarser, 60 meters, I have to tell GRASS that I want to work at that different resolution. So I have to go into my settings, computational regions, and I have to actually set the region with this little window called G.region, and I click on the resolution tab and I put the resolution that I want. Let's say I want to go up to 15. I put it here, I hit run, and I can close that. And now when I say computational region show it, I have the same boundaries, but now my raster resolution is 15. So any new map that I make will be at a 15 meter resolution. This is really important because if the finer you set this, the longer it's going to take because you're giving it more ones and zeros to crunch. My suggestion is that since we are working with the 30 meter resolution base data, let's go ahead and set our computational region to match that. And now we're back to 30 meters and everything we do is going to be at that 30 meter resolution. But you need to be cognizant of this in GRASS because again, you are driving the bus here. You need to know to deal with these things. Okay, so now that we've got sort of the basics of GRASS data and how the data is managed, let's talk a little bit about the interface of GRASS and how you'll be working with it. Much like QGIS, you've got this sort of menu items at the top, but they're a little bit more, they're a little deeper, let's say, right? They're organized in the same kind of way, raster, vector, imagery, 3D rasters, database, all this stuff. But then you've got a couple of, got a lot of different sort of subheadings, and each one of these things is a module, a tool that will let you do some kind of GIS operation. Now GRASS, at the very beginning, was a command line interface way back when, right? And it still has that underlined. And again, depending on how you're launching GRASS, you may see this terminal or you may not. But you can literally type in any command that you can get from the menu. You can type it into here and you can work with it. So, for example, all the raster tools start with this R dot, right? And let's say we wanted to do a moving window analysis with R neighbors. I can do it like that through the menu and get R neighbors. But I can also type R neighbors and R neighbors and hit enter. And and it will pop up over here, right? So I can do it there. Over here, let me move my face over. Over here in the Info tab, we actually have a couple of ways of interacting with GRASS modules. Firstly, the first tab, Tools, we basically get a mirror of all of those file menus, but with these little carrots, right? So every raster tool that's up here under raster shows up over here. And for example, there's our neighbors, and I can double click on it and it pops up over here. We also have the Console tab, and the console is where the output information from some of the default modules shows up. We can also type commands here. R neighbors, oops, I put comma, R dot, and you can see it will start to autofill, and I can click on the autofill, double click, and now I can hit enter, and our neighbors pops up here, right? Multiple ways to get the same kind of functionality. And of course we have, if we really wanted to do it, we could even get into the deep down programming API for Python, and I could pop up modules over here if I'm going to get into that level of geekery, which I personally do, but you may not, right? So essentially you can choose the way that you interact with GRASS. You can do it old school from the command line, and us old users often do that, but you can also very simply use the tool interface over here, or just the pull downs over here. And each of these modules will pop up with a new window. And again, R dot for all the rasters, V dot for all the vectors, I dot for all the imagery, R3 for the 3D rasters, D for the databases, and then we have G for the general tools, and D for the display tools. Like, there's a lot of this kind of legacy from the command line interface. Each module will have several tabs that you have to kind of work your way through. So your tabs may be across the top like mine, or they may be down the side by default, depending on, again, the defaults that shipped with the way you installed GRASS. But each tab has some inputs that you have to set, or output names of maps and stuff. And they also have a manual tab. Each one of them has a really detailed manual page. So you just click on the manual and it will tell you what all of the options are, and it will give you some really good explanations of what the operations are doing. And you can read into as much of this as you want if you really want to understand what is happening. A lot of these modules are very well documented. This particular one is very, very well documented. And it'll give you some examples of how you could do this with the sample data set. It will show you related operations. It will tell you who created it. And you can actually get a link right to the source code. And often, they'll even have references to the scholarly literature for the operation that is encoded in GRASS. Now, this is why I love GRASS so much. It is open science, like all the way down to the core. It's the heavy lifter, right? QGIS, I think, is a little bit of an easier intro. It definitely has really good cartographic composer, like creating that map interface, or the interface to create those graphical map products is really, really good. It's a little simpler to throw data in on the fly when you're working in the field and that kind of stuff. It has some cool plugins like to bring that Google satellite imagery down, and all of that stuff is really great and very, very useful. But when you want to start doing major operations, yes, QGIS can do a lot of the same stuff that GRASS can do, but GRASS is going to do it more efficiently, and it's going to manage your data better, and it gives you just a lot deeper information, and it adheres, I believe, a little bit better to those ideals of open science because of all of this stuff. Okay? All right. So what we're going to do is to use our neighbors to create a let's call it a blurred version, a coarser version of our SRTM data. This is just an initial foray for you to explore how GRASS modules work. So the first tab is required. if we happen to have had our SRTM highlighted over here, it will automatically pull it in. Otherwise, we click the caret and we navigate to the data file that we want. We want 1 basically now, so we click that. And now let's call our output. We're going to blur it to like the 120 meter resolution, right? So HASA, and this is technically called a low pass filter, 120 meters, okay? And now we have to actually set that, right? So in the neighborhood tab, we need to set the neighborhood size. And this is in number of raster pixels. So our pixels are 30 meters. We set that with our resolution. Now we know that if we go 3 pixels, that's going to get us to 90. And if we go 4 pixels, that'll get us to 120. Now we pick our operation. In this case, we're just going to click leave the average when clicked. But we could choose any of these statistical operations, like we talked about in class on Monday. And then we have some options that we could work with over here. We don't need these for what we want to do. We might want to set our memory a little bit higher. By default, it just says 300 megabytes of your RAM. You probably have a lot more than RAM, so I'll set mine to 3,000 megabytes. Just makes it go a little bit faster. And then we hit run, and oh, it's not going to let me do that yet. Let's go to 5, and then we'll call this 150 meters. Okay, so we'll hit run, and it's done. So this is the output window of our little module. It tells us we're done. We can hit close if we're happy with it. And now in our new map set, we have the HASA low pass filter 120, and it adds it to our map display over here. And it may not look like anything different when we're all zoomed out, but if we zoom in, like so, to this little area over here, and over here we can sort of quickly check and uncheck. Let me just make this window a little bit bigger so that I can do that. We can actually see this is the original 30 meter resolution, and here is our blurred at 120 meters. Now technically this map still has a 30 meter cell interval, because that is the resolution that we set our region to. But because we made this moving window of 5 by 5 pixels, and we put the average value, each of those cells at the 30 meter resolution is actually the average value of elevation within that 5 by 5 neighborhood around it from the original SRTM. And so effectively what we're doing is looking at data at that coarser 150 meter resolution. Okay? So that's our first map that we did with a moving window analysis, just like we talked about in class. Another way to do this is to do a kernel density. So we'll use another moving window, but we'll instead count the density of points within that window size. So what we can do is go to raster and go down to where it says generate surfaces, and go down to where it says Gaussian kernel density surface v.kernel. Now this is going to, again, you're going to create a moving window of a certain number of pixels of the raster resolution, and it's going to move across the whole area, east to west, north to south, and it's going to count the number of points of the vector file that you're going to tell it to look at, and it's going to create a new raster with basically the count of those points within that neighborhood. So each 30 meter pixel is going to be the count of the number of points that are within the neighborhood of whatever size you tell it. So the first thing in the basic tab is going to be picking, let's pick the WHS sites. That's the map with training points. Then we got to give an output map. So let's call this WHS sites kernel density, and then we have to decide what resolution that we want to do. So I'll do it at like a ½ kilometer, so 500 meters. And here it says kernel radius in map units. So previously it was asking for number of pixels of the raster resolution. Here it's actually asking for a value in meters, because we're in UTM, we're dealing with meters, and so we have to put specifically the number of meters that we want the circular radius to be. So if we write 500 here, that'll be 500 meters. There are a few other things here. We don't need to deal with them at this particular moment. We can read the manual basically for some of these other things, but basically we are going to be dealing with the defaults in this particular one. So we'll just hit run and it will do its thing, and there we go. So if I turn the Hasa sites vector off, we have this map and the colors are relating to the density. So if we want to put a scale bar, we'll just make sure that the kernel density is highlighted. We'll go up here to where it says add map elements and we'll click add raster legend, and by default again, if we have it highlighted over here, it's over here, and we'll just hit OK, and it'll stick this raster legend here, and it will just tell us what the color scale means. This is the actual density value. I can right click on this and I can click resize and move, and if I want, I just draw the size that I want it to be, and it's over there now, slightly smaller. If I double click on it, I can go in to the actual individual settings for the legend, and I can like change the number of labels, and I can change the font of the labels, and I can, in this case, what I really just want to do is to show the background like so. And as long as I have this little arrow pointer, I can actually just click and drag it and move it around as I want. And if I want it to go away, I can just remove it over here like so. Okay. So in the background, or over here actually, we still have the kernel. We can go back in here and we can change this to 1,000 like so, and we can do it at 1,000 meters like so. And we can hit run, and there we have the kernel density at 1,000 meters, right? So now we have two different spatial scales of gathering up how many points are within that neighborhood. Pretty cool, right? Okay. Last little bit that I want to talk about is how to delete things. So let's say I don't like this 500 meter one and I want it to be completely gone. There are multiple ways to do this. The old school way is to go into the file menu, to go down into the manage maps and find the g.remove delete maps, and then you have to click raster map, and you have to find the name of the map you want to delete over here, and then you'd have to click this force removal button and then hit run, and then it will delete the map for you. This is safeguard so that you don't accidentally delete data that you don't want. So that you can do it that way, but you can also go into this area of the file manager, and you can find the map that you want to delete. You can right click on it and you can hit delete, and then it will ask you, do you really want to delete this? And if I do, it's gone. There's no way I'm getting that back. It's not in a trash file somewhere, it's gone off your computer, okay? So you need to be a little bit careful about that, but that is obviously useful if you've made a whole bunch of maps and you just want to clean them up and get rid of them. But by default, it's going to save everything you do in this current map set. So you can have a map set where you're just playing around and making a whole bunch of nice, crazy maps. And again, you can then right click on the map set, and if you have it enabled to delete them, you can delete that map set. And all the maps will go, and they will be gone off of your computer. Not in a trash file, but gone. So again, it just makes you click a few things and be sure you want to do it before you do that kind of stuff. Another thing that you might do is want to just continually overwrite maps. And in this particular example here, it's not the greatest because we did like 1,000 meters. So if we changed this to 10,000, obviously we would want to change the name of it. But let's just pretend we want to redo this analysis, but we want to just overwrite this same map that we wrote before. To do that, again, it's a safety check. Go to the optional tab and click allow output files to overwrite. It doesn't allow you to do this by default because it doesn't want you to accidentally overwrite something you didn't want to overwrite. You have to go in there and tell it that you want to do it. And now, when you run it, and again, the larger the window, the longer it's going to take here, but now it's doing it at that 10,000 meter level, and it's going to overwrite that previous map. And when we look at the output, now we have the kernel density at that much coarser level. Of course, because we didn't change the name, the file still says 1,000 meters, even though this is 10,000 meters. If we want to change the name, we could go again to File, Manage Maps, Rename, and then you have to put in the one that you want to be renamed, and then you put a comma, and then you type the name that you want afterwards. Super old school. So instead, you should just right-click on the, double-click on the thing over here, and you can literally go in here and edit it with 10,000 and hit enter, and now the map is actually renamed. Very, very simple, a little bit simpler than the old school way. So again, GRASS has a lot of legacy to it, and there's more than one way. Sometimes there's multiple more than one ways to do things in GRASS, but you'll find the way that you want to interact with it, and you'll start to work, in your